What are chemical bonds? There are intramolecular bonds, which are bonds within each molecule, and there are intermolecular bonds, which are bonds between molecules. Let's look at intramolecular bonds first. These are bonds within the molecule. There are three main types of bonds. Firstly, you have covalent bonds. These are bonds found in water or hydrogen. Secondly, ionic bonds. You can find them in sodium chloride, also known as table salt, or calcium hydroxide. Thirdly, metallic bonds. These are found in metals such as zinc and iron. Let's find out more about covalent bonds. Covalent bonds are bonds between non-metallic atoms. For example, water. The aim in covalent bonding is to create stability between the atoms. This is done by sharing outer shell electrons between different atoms so that the outer shell has 8 electrons. This is known as the octet rule. The sharing of electrons create a covalent bond. Each of these pair of electrons are known as a shared pair. As these bonds are super stable, they are super strong. There are two types of covalent bonds, polar and non-polar covalent bonds. This is driven by the electronegativity between atoms bonded by the covalent bond. Electronegativity is the power of an atom to attract electrons to itself. Each atom has its own electronegativity. For example, chlorine has an electronegativity of 3.6, hydrogen 2.2, nitrogen 3.04, fluorine 3.98. Polar covalent bonds are formed when the two atoms bonded together have an electronegativity difference of 0.4 or more. In polar covalent bonds, a dipole moment is formed between the partially positively charged atom and partially negatively charged atom. The greater the electronegativity difference between the two atoms, the stronger the dipole moment. The most electronegative element is fluorine. On the periodic table, the electronegativity increases as the element is closer to fluorine. Nonpolar covalent bonds are formed, on the other hand, when the covalent bond is between two atoms with an electronegativity difference of less than 0.4. Covalent bonds can come in multiple bonds. This correlates to the number of shared pair electrons. In general, the greater the number of bonds between the atoms, the stronger the bond. The next type of intramolecular bonds are ionic bonds. These are formed between a metal and a non-metal. Ionic bonding occurs when one or more electrons are donated from one atom to another. This creates a positively charged ion or cation and a negatively charged ion or an anion. These oppositely charged ions attract each other through electrostatic forces and form an ionic bond. The last type of intramolecular bonds are metallic bonds. This is formed by the electrostatic attraction between positively charged metal ions and delocalized electrons. These electrons are from the outer shell, also known as valence electrons, and move around freely. This forms a lattice of positively charged metal ions in a sea of electrons. So to sum up, intramolecular bonds are bonds within the molecule, and there are three main types. Covalent bonds, which are bonds between non-metals, ionic bonds, which are bonds between metals and non-metals, and finally metallic bonds, which are bonds in metals. Now let's look at intermolecular forces. There are bonds between molecules. There are also three main types. Firstly, there are dipole-dipole interactions, for example between hydrogen chloride molecules. Secondly, there are hydrogen bonds, for example in water. And thirdly, van der Waals forces, also known as London dispersion forces, like between chlorine molecules. Firstly, we have dipole-dipole interactions. These normally happen between polar covalent molecules. These are forces between the partially positively charged part of a molecule and partially negatively charged part of the neighboring molecule. The next type of intermolecular bond is hydrogen bond. This is a special type of dipole-dipole interaction. Examples include hydrogen fluoride and water. This is limited to molecules with hydrogen covalently bonded to oxygen, nitrogen, or fluorine, which then interacts with another strongly electronegative atom. The final type of intermolecular force is van der Waals forces, also known as London dispersion forces. These are forces which are created by induced electrical interactions between two or more atoms or molecules which are close to each other. This type of force is found between all types of molecules. So in summary, there are three types of intermolecular forces. Firstly, there are dipole-dipole interactions, which are found between polar covalently bonded molecules. Secondly, hydrogen bonds, which are found in polar covalently bonded molecules with a HF, HN, or HO bond and another electronegative atom. And finally, van der Waals forces or London dispersion forces, which are found between any